Okay, this is going to be about how carbon-14 dating works and the pitfalls involved in it, and some surprising data yielded by it. So, it's been determined that cosmic rays create unstable. The carbon atom is very stable, so there's the normal carbon is carbon-12. There's also carbon-13, which is stable, which I'll talk about in a little bit. But carbon-14 is produced when nitrogen is struck, and it's got a half-life. So let's go. It's made in the atmosphere. Carbon-14 forms dioxide. Plants eat it. Animals eat the plants, and when they die, they stop taking in carbon-14. It begins decaying to form nitrogen-14. So here we go at death. There's 100% carbon-14, and then the half-life is 5,730 years. So every 5,730 years, you lose half of the carbon-14. Now, there's an interesting caveat to this. When you find a piece of carbon, when you find something you want to carbon date, you have to give them a ballpark figure. So the further back you go, the more inaccurate it becomes. So the first half-life, they can probably get it within, 40 years. Then it jumps, the uncertainty goes back, the further you go back every time the half-life goes. Also, there can be misidentification with water if water's runs over your sample, because it's going to wash other carbon onto it. For instance, they carbon dated a I Like Ike wooden button at several thousand years old, and it was actually made from a tree that was made 20 years earlier, and it was on the side of the road that they found it. So Eisenhower was elected president. Depends on which, it could have been his first or second term, but it wasn't any later than, wasn't made any later than 58 or any earlier than, he took over after Truman. So, obviously the date's wrong. I have an interesting story to tell. So I went to the Powder River Basin, where we have the largest coal reserves. They're unexplainable how they're set down. They're hundreds of miles long. They're 200 feet deep and 500 yards wide, and they're pretty much pure coal. And at the top, you go in these mines, and they're miles and miles long, and you go in there in electric carts, and in the ceiling you can see footprints that are obviously dinosaur footprints. And there's wood that hasn't actually turned into coal there. And we've taken samples out of there, and I oversaw the samples taken. And they took it to a place called Miami Analytical, where they did the carbon-14 dating, and they brought some coal samples from Germany with the same thing, and they all tested very young. So the coal deposits were laid down very young, and carbon dating will not work on something as old as they say it is. I mean, they were saying these were laid down in the geologic column. They were saying it was the Pennsylvanian age, and they just make up stuff with that. But anyway, how when they get a sample, they like to shave the outside off, and then they rub it down with usually 3 solvent baths. Well, at the end of that, they consume it with an acid, and then they turn it into graphite. And graphite is pure carbon, and that's the point where they age it. And they use a mass spectrometer to set the age up. So, if you wanted to date something, it's probably pretty accurate in the late Archaic age. The Archaic period. But you're really pushing it when you get past into the Clovis period. The further back you go, the more uncertainty there is. And there's another thing I want to talk about. It's called the Seuss effect. and if your sample was near a roadway where there was a lot of mufflers, like right near where your thing, so as the cars are driving past, say you have an auto bank where they've dug into the bank, and there's a piece of wood exposed. It's actually going to get carbon from the burning of gasoline, is going to change the date on it. So if you're near a place that has a lot of machinery running, it can throw off the dating process. So it's really not even as accurate as tree rings. And anyway, I really think that the way to really do it is carbon 13 dating. So carbon 13 is a very stable form, and it's not affected near as much as carbon 14 is from the burning of gasoline, which releases some carbon 14, which can get into your sample. So radiometric dating is absolute in a lab, but in the real world, there's all kinds of variables that can come to it. So, like I said, to make carbon dating work, you shave down the sample, you treat with solvents to get all the impurities out, and you melt it with an acid to turn it into carbon dioxide, and you turn it into graphite, and then that gives you the raw amount of the carbon 14. And that's all. I'm out.